Okay, last class we have solved this type of equation by Lagrange method. Okay, so this class will be on higher order partial differential equation, and okay, here we will consider only dependent variable z, which is dependent on x and y. That is, our independent variable is only x and y, and your dependent variable is z. Here we will consider only two independent variables. Otherwise, in partial differential equation, you can have multiple number of independent variables. Okay, so now suppose we have a partial differential equation between z and x and y. So a general, that is of higher order partial differential equation, may be written as, suppose it is nth order, so I will have this type of terms. It's a general nth order, and your this is n, so it is n, and that is, we will contain all types of terms differentiation with respect to x and y. Suppose I have to join. You cannot use the link for joining. I have edited the time, so I think it was convenient if you could have joined by the link. Otherwise, I have to enter so many people now. Okay, now it's 43, and I think only 50 is doing the class, around 50. So maybe. Okay. All orders of partial differentiation which is possible, we can have all the terms, or maybe some terms won't exist, that is, their coefficient will vanish. That is a general nth order partial differential equation where your dependent variable is z, independent is xy. We can have so many differentiations of this type. Okay, so the function, that is a relation between all these, that will be our partial differential equation of nth order general. And now if the degree of these partial derivatives all is only 1, then we will call it is a linear. Okay, so this is our linear partial differential equations of nth order, and where this P0, P1, Pn, Q1, all the coefficients, that is M1, NO1, C. This is C multiplied, that is a constant multiplied with Z. So this C, all either functions of xy. If they are functions of xy, then it will be called a general, and if all of these are constants, then it will be higher order partial differential equation with constant coefficients. Remember, in ODE we have solved those type of equations where those were constants, and we have solved those ordinary differential equations. Like this, we will solve this type of equations where this P0, P1, Pn, these are constants, and in general these may be functions of x and y, but we will here only solve the equations with constant coefficients. So, and we will use the notation you remember we have written this d as there ddx. Here this will be represented by del x, and this will be represented by del y. That means someone is joined. Okay. That means if I have TR, that will implies del R del X R. If it implies del S del YS. Suppose I have a term like this is operated on some Z, this will be equivalent is okay. So these are all notations we will so suppose I write this notation in these equations. So this will be dn, this will be, so whatever equation I have written there, I can write this as P0 dn. I am writing the these notations in place of this. So this is P1 d n minus 1 d dash plus Pn d dash n plus Q1 d dash n minus 1 m1d plus n1d dash plus c. And suppose I am writing this equation, that differential equation is written as d dash operated on z. That means it will be operated on z. And suppose I have a equation, right side I have a function fxy. So if your partial differential equation is like this, that is where this f d dash is this. I have written, it may happen your sum of the constants may be 0, that means those differential coefficients won't appear in the equation. And your right side there is, you remember in ODE, your left hand side the differential operator, and right side there was a function in only x. Here independent variable is x and y, so you will have a function in x and y. So we will first find out complementary function, that is putting this is equal to 0, and solving this we will get the complementary function. And for pi we have to integrate this, and there will be rule, so that we will be able to find out the particular integral, and the complete solution will be CF plus PI. So, and here you one thing we have to remember, that we have considered here a homogeneous equation. That means I have taken this, suppose, in a way such that your all p plus q is n. Okay, so this is n, this is n minus 1, 1, this is n. Okay, so if nth order homogeneous equation, then only this term will appear. These terms won't appear. But since it is a general equation, so we have taken this as a general form. Now, so suppose we have to solve this equation, this partial differential equation. So the general solution of these will be CF, that is complementary function plus particular integral. That is, we have generally, this is written as this. Okay. Now, for finding, first we will find out the complementary function. Okay, so first we will, the complementary function of these partial differential equation we will have from this general solution of this equation. So first we have to find out the solution of this. So that will give you the complementary function of this equation. So first we will start with this complementary function. Now, since suppose my differential equation is of nth order, so it may happen that I can factorize this term, this coefficient of, that is, which is operated on z, this term in factors of, like, suppose a1d plus b1d dash plus c1 into, that is, I will have n terms like these linear factors of this equation. And we should remember one thing, a2d plus b plus c2 is equivalent to, there is a theorem, I will give you the PDF that is proved. So I am not giving you the proof, but if someone is interested, there is the proof. Okay, so that means in either way you write down your factors, doesn't matter, the result will be same. Okay, so we will factorize these, suppose it is of n, suppose is n is equal to 2, so we will have two factors like this. If it is nth order, so I will have a1 to, oh, this is b1d dash plus c1 a2d, where a, b, c are constants. So since it is of nth order, we should have AND BND dash plus Cn. This is equal to our FD dash. So there will be n factors. So this can be written as, we will equate, this is right side is equated on, suppose this is operated on, this FDD is operated on Z, so this is equal to 0. So we will have each and every, so we will solve this, that is B1D dash plus C1Z. We can individually solve each of them, and we will then sum all of the solutions and we will get our CF. Okay, so suppose I am taking a general term like ARD plus BR. R is the general term, that's why I am taking this R. So I can take any ABC you choose. So I will solve this, okay? And you can find, this is dz is del z del x, this is del z del y. So it is in the form, and we know how to solve this type of equations. So our Lagrange auxiliary equation will be dx by ar is equal to dy by dr is equal to dz by minus. Okay. So first we will solve between these two, and this will be nothing but, uh, from these two relation I will get integrating a over y minus brx. There will be an arbitrary constant. Suppose I am writing this arbitrary constants as, I am taking ABC, so suppose this is I am taking as D. Okay, so these two, from these two I will have this, and from, suppose I am next, I will equate this one and this one. So dx by ar is equal to dz by minus crz. So log z is equal to minus CR by ARX at a constant term. So I can write this Z is equal to some constants D2 e to the power minus CR ARX, provided this AR not is equal to 0. This AR not is equal to 0, otherwise it won't be valid. So I can now write the general solution of these as Z is equal to e to the power minus CR AR by X, and I can arbitrary function of phi ARY minus BR X, where this AR not is equal to 0. AR not is equal to 0. Similarly, if I do equate these two, I could have got e to the power minus CR BRY. Suppose this is phi 1, so I could take phi 2 ARY minus BRX, where BR not is equal to 0 for this term. Okay, here. So this is the your CF of these. So I can have n of these terms from all the factors n, then I will sum all these solutions and I will get the complementary function of this. So suppose my differential equation is, okay, this is, I am writing this VRT dash here, then my z will be r is equal to 1 to n e to the power minus cr by ar x phi r ar y minus, or it may be in this form, or maybe you can take any one of them. Okay. And suppose if some of the terms are repeated, then we will have the form in Z. Suppose I have a term like AD plus C. This is repeated 8 times. Okay. Then the solutions of these will be this will be R. This is repeated 8 times. So this will be R x to the power. You remember in OD we have multiplied by here also this, and ay minus bx a naught is equal to 0, or I may write this as okay. Suppose I have a equation like okay, I can see that this can be written as right. So this is one factor and this is another factor. So I can here your a is 1, your b is -1. So I can use the formula of this, and okay, and I can write the formula. So what will be your solution? Will be z will be here your c is 0, so this term won't exist. Okay, for the first equation, this c is there is no c, so this term won't exist. Only exists this term. So z is equal to phi 1, and the coefficient was only 1, so 1 is y, and another is -1, that is -1 so plus x1. And for the next, that is d plus d dash plus 1, your c is 1, so there will be a term e to the power minus c by a is 1, so this will be minus x, and that will be phi 2, and this is y, and the coefficient is plus 1, so this will be minus y minus x. This is complementary function CF. CF is equal to this. So you will be able to find sometimes if the factor, if it is suppose my f TD is not reducible in this linear factor. Suppose I cannot write in this way, this factor. Suppose I cannot decompose in these factors, then what we will do, if it happens that some parts can be factorized, then some we will factorize and we'll get the solutions like this. But for the other, which is non-reducible to this factor, we will take a complementary. First, we will take a trial solution such that they will be like e to the power alpha x plus beta y. We will take a trial solution I like this, and we will apply, suppose this d dash, we will apply this on, for we will take z is equal to this, then we will apply the differential operator, then whatever irreducible form it gets, then we will get this and solve this. Okay, first we will start from the simple ones, that is which is reducible. So I know you will be able to solve this. You will be able to solve this. Solve it.
Ma'am, this will be z equals to first, that is z equals to f1 of y minus x plus f2 of y minus 2x.
Y minus 2x.
2x প্রথমটা y. হ্যাঁ,
Okay. Okay, so this is the complementary function of this. Now it has a repeated part, so now solve this one. Have you done the second one? Okay, so this is a repeated root. So general solution, the first will be in this form. That is the solution will be same, but there will be a multiplied by factor. Since our s is 2, so this will be only multiplied with x. S minus 1, okay? So that will be 1 only. So the solution will be okay, z is equal to e to the power c is minus x c by a, and this will be sum of 1 is pi 1 plus 1, so this will be y minus x, and another will be multiplied by pi 2 y minus x. Okay.
হ্যাঁ ম্যাম এটাই এসছে
Okay. So this is the complement. Just remember that will be just the same where the summation will be on, and if you multiply it by x, suppose this is cube, so there will be another term x cube x square like this. And it was in the same like as in ODE, right? Remember? Okay. So I will send you a exercise for this. I hope you will be able to do this type of problems. Now, suppose my function is not reducible. Like I am starting with an example. Suppose I am d minus d dash square. So you cannot factorize in linear factors because these are not same. So this is equal to 0. So this you won't be able to factorize in any linear factor. Then for this type of equation, we will take a trial solution like z is equal to c, that is an arbitrary constant. Suppose I am right. So okay. So that means dz will be ca e to the power ax plus by, d dash z will be cb e to the power ax plus by. If I repeated, that is cb square to the power ax plus by. I am just taking the steps, otherwise you just directly apply this on. So what we will have, I will common is c, there will be a minus b square e to the power ax plus by is equal to 0. Now, since we know that if this c is 0, so your solution will be a trivial solution, so your c cannot be 0, this term cannot be 0, so that means your a should be a minus b square is 0, implies a is equal to b square. Now, so you will have your trial solution. You will put a is equal to b square here, and you will get your general solution like z is equal to summation ci. This will a is bi square x y. Okay. So you will have arbitrary constants, this c1, c2, i5, and you will get your general solution of the given partial differential equation like this. Suppose you have an equation like d minus 2d1 d minus you know how to solve, you know this CF, the complementary function of this part you can derive using the previous formula, and for this non-reducible part you will take the trial solution z is equal to c e to the power ax plus by. So for this part your solution will be, what will be your solution? This is 1, so it will be e to the power x e to the power x by 1, then that will be 5 1, this is 1 minus 2, that means the complementary solution for this part, that is solving this d minus 2d dash minus 1z is equal to 0, you have got this part. So summing this part, and for this part you will get the complementary function of the original differential equation. And for d minus 2 z is equal to 0, you substitute z is equal to c e to the power x plus bi. So for you see this will be a minus 2b square minus 1 e to the power ax plus by is equal to 0. You know this term won't vanish, so your a minus 2b square minus 1 is equal to 0 implies you will put a is equal to 2b square plus 1. So in the general solution, you will have summation ci e to the power ax. You will put 2bi square plus 1 and plus plus biy. So this is this, and you will sum this e to the power x phi y plus 2x. This is your complementary function z. Okay, so you will be able to do this type of problems. Okay, now for pi, suppose I have the right side function as e to the power ax plus by, and uh, then my, and remember your fab not is equal to 0, then pi 1 by f dt dash e to the power x plus by will be, this is your I'm suppose I have a function z is equal to f xy. So this fxy, I should have write this is at fxy. Suppose your right side is this, and then this will be your feb. This will be your this shouldn't vanish. So this will be fab is equal to not is equal to 0. So I will put this one b into the like the previous in the ODE, you will put a in place of this d, and you will put b in place of this d dash, and you will get your particular integral for this equation, for this equation. So suppose I have an example. Okay, suppose I have an equation d square minus d dash square d minus d dash z is equal to e to the power 2x plus 3y. First you solve for the CF, okay, and tell me that is, you know, this will be your d minus d dash into d plus d dash plus 1. So you know what is your CF. What is your CF? Yours will be A is 1, this is minus 1. So your e to the power term will vanish because C is 0. So CF will be 5, 1, 1 is 1, the minus minus a plus, that means this. And for this your C is 1. So this will be e to the power minus CR by AR. So minus X pi 2. This is 1, this is 1. So the 1 will be minus. Your CF is this. And for PI, and you agree with this CF? This is the same like previous. And for PI, your PI will be 1 by, that is, my factor is d minus d dash, and d minus d dash into d plus d dash plus 1 e to the power 2x plus 3y. So remember the formula was, if this doesn't vanish, so we can write is in place of d we will write a, in place of d dash we will write b. So this will be nothing but 1 by 2 minus 3, 2 plus 3 plus 1. So this will be minus, there will be only a minus left. Okay, I am writing down the 2 minus 3 and 2 plus 3 plus 1 e to the power 2x plus 3y. This is nothing but minus 6 e to the power 2x plus 3y. So your complete solution will be Z. You will add your CF. There was e to the power minus x pi 2 y minus x minus 1 by 6. This is your complete solution of the partial differential equation. Okay. Now solve this equation. D square minus dd dash minus 2d একটা সেন্সিটিভ হয়ে গেল কি করে? Okay, what is happening? Solve it. Have you done this? Okay, so this is the solution. Have you got this, or you have got this result or something else? Okay, okay, probably. So I think it will be, you will be solved this type of problems till that means this type of e to the power if you right side of this. So in the next class we will do for finding particular integral. If this is, suppose this is some function of sine, cos, like the previous ordinary differential equation, there are some rules. For suppose this is the similar like the ODE, so there will be some kind of sine of or x to the power polynomial or something like that. So next class we will do the other particular integral forms. And okay, so for today this is your, I will send you the exercises or the PDF so that you can solve the problems for up to this. Okay, so there are 3 exercises, I think. I will send you the PDF by today, right? By today evening I will send you. Okay, thank you.